Don't leave this button on, or you could be destroying your engine without knowing it. It's a feature found in millions of modern cars, marketed as an eco-friendly fuel-saving solution. But the reality is different. Every time it's activated, it subjects the engine, battery, and starter to brutal wear and tear. The irony is that manufacturers present this as an advancement, when in reality it can drastically reduce the lifespan of your car. And this isn't the only case. Today, you're going to discover the truth behind 10 modern features that are destroying your car without you even knowing it. Number 10. Start divided by stop button. The famous start divided by stop button was born as a modern solution to save fuel and reduce emissions. In theory, it sounds logical. If your engine shuts off at every stoplight, you use less gas. But behind that ecological promise lies one of the biggest silent enemies of a modern car's reliability. Think of it this way. Every time your car stops and restarts, it's not just the engine that's working, but also the crankshaft, spark plugs, bearings, and most important, the starter, motor, and battery. These components weren't designed to withstand thousands of additional starts per year. Under normal conditions, a car starts about 2,000 times a year. With the start divided by stop system activated, that number can increase by up to 10 times. The result? Studies by independent manufacturers have shown that each startup is equivalent to about 500 kilometers of accumulated wear. In other words, that seemingly harmless click is actually invisibly shortening the life of your engine. One of the most affected is the starter mode. In cars without start divided by stop, this component is designed to easily last more than 100,000 starts. But with this system activated, that limit is reached in less than 3 years of urban use. And when it fails, it's not a cheap replacement. Replacing it can cost between $400 and $800. The battery also suffers. Cars with start divided by stop require special AGM or EFB batteries designed for more intense charge and discharge cycles. However, even with this technology, their lifespan is reduced by up to 40% compared to conventional batteries, and this costs no less than $300 to $500 each time they are replaced. In addition, this system generates additional vibrations in the engine when it is repeatedly turned off and on. These vibrations can wear down mounts and sensors, and even affect the smoothness of cold starts. One only needs to look at owner forums to see a repeated pattern. Drivers manually deactivating the start divided by stop system because they notice their car shudders at every stoplight, or who, after a few years, experience recurring electrical failures. A clear example is that of BMW and Ford owners in the United States, where complaints about premature battery failures have skyrocketed since the system became standard. In Spain, independent repair shops have reported that up to 25% of new car service calls are related to battery failures in models equipped with start divided by stop. And the most ironic thing is that most drivers don't even notice significant fuel saving. We're talking a maximum of 3 to 5% in real-world conditions. Add it all up, and the supposed savings on gas, about $50 to $100 a year, are dwarfed by the additional costs. Starter motor $400, $800, AGM divided by EFB battery $300, $500, possible affected sensors $100, $200. In total, a complete failure of this system can easily empty your pocket by more than $1,000 at once. The most worrying thing is that this system wasn't designed with engine longevity but rather to meet emissions regulations in laboratory tests. In practice, this eco button could end up being a silent engine killer. Many mechanics recommend disabling the start divided by stop manually whenever possible, especially on urban routes where the car is constantly stopping. While you may save a little gas, the cost you end up paying in repairs is much higher. And be careful, because if you think the start divided by stop button is the worst button that can destroy your car, I'm warning you, you haven't seen anything yet. What appears at number 1 on this list not only damages your engine, but it can cost you up to 10 times more than start divided by stop repairs. Number 9. Touchscreens and haptic controls. Touchscreens arrived with the promise of modernizing everything. Buttons on the outside, shiny glass on the inside. The idea was futuristic, controlling your car like a smartphone. But the reality is far less glamorous. These seemingly convenient screens have become one of the main sources of failure in modern cars. The problem is simple. Unlike a $2 mechanical button that could last for decades, a screen is exposed to heat, humidity, scratches, and software glitches. All it takes is one summer of extreme temperatures or constant humidity for it to start failing. And when it does, It's not just a matter of losing a secondary function, you're also losing control of basic elements like the air conditioning or heating. Imagine being in the middle of summer, under a 95-degree sun, and discovering that your car's screen no longer responds to touch. You can't turn on the air conditioning, you can't lower the temperature, and the worst part, the repair isn't just a matter of tightening a screw or changing a button. You have to replace the entire unit. And here the costs skyrocket. We're talking between $1,500 and $3,000 for a new screen. And that's just for the spare part. If you add the labor and software reprogramming, the bill can be even more painful. And the most frustrating thing is that the car itself is still functional. The engine starts, the wheels turn, but you can't operate the most basic functions because someone decided a button was too old-fashioned. In countries with extreme climates, the problem is compounded. In the United States, for example, southern states like Arizona and Texas have reported thousands of complaints from users who have seen their screens die in less than 5 years. In Europe, constant humidity has done the same to models from brands that promised premium technology. And it's not just a reliability issue, it also affects safety. In the past, turning on the heater while driving meant simply turning a knob without taking your eyes off the road. Today, you have to look at a screen, search for the right icon, and press it repeatedly, distracting yourself for precious seconds. The technology that was supposed to make everything easier has actually become a dangerous distraction while driving. The most ironic thing is that many of these systems are mandatory. You don't have the option of ordering the same model with classic buttons. Even the most traditional manufacturers have decided to eliminate physical controls, forcing the user to rely on screens that don't always work as they should. Some specialized workshops have begun offering partial repairs, such as replacing damaged touch modules or reprogramming frozen systems. But this isn't always a definitive solution because the root of the problem remains the same, an interface that was never designed to withstand real-world automotive use. And manufacturers know this. That's why warranty contracts often exclude screen failures after the first 3 years. For them, it's a wear and tear component, like a battery or a tire. But for the user who may face a $3,000 expense for something that previously cost $20, it's a huge blow. And here's the scary part. If a screen can leave you stranded in the middle of summer, imagine what can happen to the systems that directly affect the heart of your engine. Number 8. Missing spare tire foam kit. For decades, every car came with something as basic as a spare tire in the trunk. It was a safety feature, a guarantee that if something went wrong on the road, you could fix it yourself and get on your way. But in recent years, many manufacturers have decided to do away with it and replace it with a foam kit or a portable inflator. At first glance, it may seem like a practical upgrade. Less weight, more trunk space, and the promise that your car will be rolling again in minutes. The reality, however, is far less reliable. The foam kit is only useful in very specific cases. A small puncture in the tread, if the tire is torn, if the damage is on the sidewall, or if the hole is too large, the kit simply won't work. In that scenario, all you have to do is call a tow truck and wait, sometimes on the road, sometimes in unsafe places. There's an additional problem that few people know about. The foam injected by the kit often damages tire pressure sensors, the famous TPMS, multi-temperature monitoring system. These sensors are mandatory in most modern cars, and their function is vital to warn you if a tire loses pressure. Each sensor costs between $150 and $200. And the worst part is that the foam can ruin more than one at a time. What seemed like a quick fix can turn into a repair costing several $100s more. The user examples are clear. A family traveling on vacation suffers a flat tire on the highway. They open the trunk and discover there's no spare tire, only a small foam kit. The damage to the tire is so extensive that the kit is useless, and they end up waiting more than 2 hours for assistance. Or the case of a driver who, after using the foam, not only had to replace the tire, but also the sensors, resulting in a bill of more than $600 for a simple puncture. By comparison, a classic spare tire was cheap and functional. Even the temporary ones, known as crackers, could keep you going until you got to a repair shop. They weren't the most convenient solution, but they served their main purpose: to get you out of a jam. Today, many cars eliminate even that minimal resource. Manufacturers justify this decision with the argument of weight saving. A full tire can add 15 kilos to a car, which they claim affects fuel consumption and emissions. But if we analyze it more closely, this reduction in fuel consumption is practically irrelevant for the average driver, while the loss in safety is enormous. A half-full fuel tank already adds more weight than an extra tire, and no one is considering eliminating. Plus, the foam kit has an expiration. It typically loses effectiveness after 5 or 6 years, so even if you never use it, you should replace it. Few drivers know this, and they end up discovering that the kit they trusted no longer works when they really need it. And then there's the cost of roadside assistance. A tow truck can charge between $150 and $250 for a short ride. On long trips, that figure can double. Add to that the price of a new tire and damaged sensors, and you're easily outweighing the cost of a used turbo, all for something that used to be fixed by yourself in 15 minutes on the side of the road. Some drivers, fed up with this situation, opt to buy a spare tire separately and carry it in their trunk. It's an additional investment, of course, but many see it as essential insurance. Because relying solely on a foam kit is like leaving home with a broken umbrella and hoping it never rains. In short, eliminating the spare tire is one of those modern decisions that prioritizes numbers on a spreadsheet over actual driver safety, a detail that manufacturers present as an innovation, but in practice leaves thousands of people stranded, paying unnecessary bills and assuming risks that didn't exist. Number 7. Compressed engines divided by reduced compartments. Modern cars boast more compact and aerodynamic designs, lower hoods, sleeker lines, and engines increasingly squeezed into smaller compartments. Visually, it seems like an engineering feat. Everything fits together like a perfect puzzle. But in practice, this trend comes at a huge price in terms of engine repairs and durability. 20 years ago, opening a car's hood meant finding just enough room to get your hands in and work. Changing spark plugs could take half an hour, and accessing a belt was a matter of minutes. Today, however, a simple spark plug change can require 4 hours of repair work, the removal of multiple parts, and a bill that easily exceeds $600. Heat is another silent enemy. Because it's so compressed, the engine can't breathe like it used to. Plastic and electrical components are exposed to extreme temperatures that accelerate wear. Sensors, hoses, and even wiring suffer in this stifling environment. A problem that was once solved with a cheap repair can now multiply into collateral damage simply because the heat has nowhere to escape. Here's the scary thing. That trapped heat doesn't just deteriorate secondary parts. It can literally cook your engine from the inside out, reducing its lifespan without you even noticing on a daily basis. Every mile you travel in a compressed car is like simmering a dish you didn't want to make. Mechanics know this well. Some shops have seen cases of engines with barely 70,000 kilometers already showing abnormal wear on gaskets and seals. Previously, these problems didn't appear until much later, and all because of a simple design detail: less space, more complication. The end user pays the consequences. Basic repairs turn into bills of hundreds or thousands of dollars, overheated engines on long trips, and the frustration of owning a new car that already shows signs of age. Meanwhile, manufacturers justify it with an oft-repeated argument: efficiency. Supposedly, by reducing space and weight, cars consume less. But those savings evaporate as soon as you step into a shop and discover that replacing a simple component has become a luxury. A common example: in some European models, replacing the alternator requires disassembling half the front end of the vehicle. What should have been a 90-minute job can turn into an operation that takes more than 8 hours of labor. And of course, the bill reflects this: more than $1,200 for a part that once cost a fraction of that. And if you think these repairs are expensive, wait until we get to the next point. Because in the next point, we're not talking about heat or limited space, but about something even more delicate: a steering wheel full of buttons that, when it fails, can even leave you without engine. Number 6. Buttons and electronic saturation on the steering wheel. The steering wheel has always been a symbol of total control over the car. Steer, brake, accelerate, and nothing else. It was simple, safe, and durable. However, in modern cars, that steering wheel has become a kind of miniature airplane dashboard. Dozens of buttons, haptic controls, and even integrated screens mean that what was once a robust component has now become a weak link in the car's reliability. Every new button on the steering wheel means a new electrical circuit that depends on wires, sensors, and microprocessors. And every additional connection is an opportunity for failure. A poor contact, a short circuit, or a faulty solder can be enough to render something as basic as the windshield wiper control, the horn, or even the airbag inoperable. The airbag deserves special mention. This device saves lives, but it relies on a sensitive electrical assembly in the steering wheel. When these systems fail, what should activate in a split second may never do so. There are reports of drivers discovering too late that their airbag was inoperative due to an electrical fault stemming from the steering wheel button. The cost of repairing this type of failure isn't low either. In many models, the steering wheel can't be repaired piece by piece, but must be replaced entirely. This can cost between $1,000 and $1,500 depending on the manufacturer. This is an absurd figure when you consider that, in cars just 20 years ago, a steering wheel could last the entire lifespan of the vehicle without any problem. Another drawback is the complexity of driving. Having 15 or more functions integrated into a steering wheel forces the driver to memorize button combinations that, in some cases, are confusing. What was intended as a safety improvement, allowing the driver to operate everything without taking their hands off the wheel, ends up becoming another distraction. All it takes is for a button to not respond, get stuck, or activate the wrong function for attention to be lost in a critical second. Electronic overload also affects maintenance. The wiring connecting the buttons to the rest of the system passes through a component called a clock spring, a mechanism that allows the cables to rotate with the steering wheel. Over time, this component wears out, causing intermittent electrical failures. Replacing it can cost several $100s and requires disassembling the entire steering wheel. Furthermore, the steering wheel's sensitive electronics are especially vulnerable to humidity. In hot or humid climates, the electrical contacts oxidize more quickly, and the plastics protecting the circuits deform. This further accelerates problems, especially in cars that spend much of the day parked in the sunday. The most frustrating thing is that, in many cases, these failures don't appear immediately. For the first few years, everything seems to work perfectly. But when the car reaches 70,000 or 100,000 kilometers, when it should still be running smoothly, the steering wheel becomes a source of unexpected expenses and potential danger. The result is clear. A component that once represented durability and control now represents vulnerability and maintenance costs. A perfect example of how the obsession with filling cars with electronics has transformed driving into a more fragile and expensive experience. Number 5. Keyless entry. Keyless entry seemed to be one of the greatest conveniences of modern cars. No need to take the key out of your pocket. Just approach it and the car unlocks, then press a button and the engine comes to life. It sounds futuristic, but behind this technology lurks risks and costs that make it a headache. One of the main problems is vulnerability to theft. Thieves use signal amplification devices that capture the communication between the key and the car. With two simple devices, they can open and start a vehicle in less than a minute without having to pick locks or make any noise. In some European countries, more than 40% of modern car thefts are carried out using precisely this method. But insecurity isn't the only problem. Electronic failures are more common than you might think. There are cases of users who, when trying to enter their own car, found themselves locked out because the keyless system stopped recognizing the key. What should be practical turns into frustration, especially if it happens in the middle of a trip, in an empty parking lot, or in the middle of the night. Repair costs don't help either. Replacing a keyless key can cost between $300 and $600 depending on the brand. And if the car's receiver module fails, the bill rises even more, easily exceeding $1,000. All this to replace a technology that, in practice, doesn't provide anything that a traditional $5 key couldn't safely and reliably solve. Another little-known consequence is the battery dependence. Both the key fob and the car's battery are crucial for the system to work. A weak battery in the key fob can leave you stranded at the worst possible time. And in the car, if the module doesn't receive enough power, it can lock the ignition or even prevent you from opening the doors. In other words, a simple electrical problem can completely immobilize the vehicle. By comparison, traditional mechanical keys rarely fail. Even keys with security chips were relatively robust and easy to replace. Today, however, the sophistication of keyless systems means that even a small failure can become a costly and difficult to solve problem. Beyond the money, there's the psychological fact. The driver never really knows if their car is completely secure. Was the system properly locked? Could a thief replicate the signal in seconds? That constant doubt is part of the hidden price paid for supposed convenience. And the most ironic thing is that, in the quest for innovation, manufacturers replaced a mechanism that was almost indestructible with one that is not only less secure, but can also fail at any moment. And the funny thing is, this isn't the only modern feature that, instead of helping you, can actually put you at risk. The next point demonstrates this in an even more dangerous way. Number 4. Electronic gear selectors. Knobs divided by buttons. Trusting your transmission to a chip is betting your security. For decades, shifting gears was instinctive. Moving a lever, feeling the metallic click, and hearing the gear click into place. It was a physical language between driver and machine. Today, with electronic selectors in the form of knobs or buttons, that language has disappeared. Everything depends on an electronic module that interprets your command and translates it into a digital action. And that's the problem. You no longer directly control your transmission. You rely on software that can fail. An example, thousands of drivers have recounted how, while parking, they swore they'd put the car in park, but it actually stayed in neutral. The result was a car slowly sliding toward the road until it crashed into a wall, a garage door, another vehicle, or worse, a person. Manufacturers sell it as a sign of luxury and modernity, a clean design without bulky shifters, with more space on the center console. But what they've really done is break the physical connection you had with your vehicle. Before, the movement of your hand and the mechanical sound were immediate proof that you were in the right gear. Today, all you have is an LED light and the hope that the computer registered your action. The problem is that electronic systems fail. A poorly performed update, an electrical overload, a sensor that ages due to engine heat, and suddenly, your selector doesn't respond as it should. The cost? Reprogramming the module or replacing it can cost between $800 and $900. And that, of course, doesn't include the damage that can be caused by an unexpected crash in your garage, or the deductible your insurance will force you to pay. The worst part is that this isn't a theoretical fear. Brands like Fiat Chrysler have faced class action lawsuits over their joystick-style shifters, accused of confusing drivers. In some documented cases, the car moved on its own because the system didn't properly lock the transmission. There have even been fatal accidents. And when a mechanism as vital as gear selection depends on a microchip, your safety becomes a given. There's no metallic noise to alert you, no mechanical resistance to confirm. Just a button, a light, and the faith that everything is working properly. But what comes next directly affects the heart of your engine. Number 3. Modern turbos and supercharged engines. Modern car manufacturers market turbos as the best of both worlds. More power and greater efficiency in a smaller engine. On paper, it sounds perfect. In practice, it means your engine is working under a level of stress that sooner or later leads to accelerated wear. A turbo is no innocent accessory. It's a component that spins at 200,000 revolutions per minute, withstands temperatures exceeding 800 degrees, and depends on constant lubrication to prevent failure. A drop in oil pressure or overheating is all it takes for the nightmare to begin. The fact is clear. The average lifespan of a turbo is less than 200,000 kilometers. That means that even if your engine is healthy, the turbo can die much sooner. And when that happens, it's not just a minor expense. We're talking repairs between $2,000 and $4,000. A common example is that of Volkswagen and Audi. Many report turbos failing even before reaching 100,000 kilometers. Imagine the frustration. You bought a modern car, trusting it would last for years, and suddenly you see white smoke coming from the exhaust, a total loss of power, and a repair that costs more than what you saved on gas. Turbo always collects its debt. The question is when. The problem isn't just the cost, but the engine's total dependence on the turbo. Previously, with naturally aspirated engines, if something wore out, you could continue driving with less power. Today, if your turbo dies, your car is unusable. Few drivers know that the turbo requires special care. If you turn off the engine immediately after a long trip, the oil inside can carbonize due to the extreme heat. Or, if you ignore oil changes, deposits damage the turbo bearing and reduce their lifespan. And even if you're careful, you're fighting against the very nature of the part. A turbo lives in an extreme environment at the limits of what the materials can withstand. It's designed to deliver immediate performance, not to last for decades. Manufacturers know this. That's why they turn to small but turbocharged engines, more initial power, and more future revenue from repairs. What's an unexpected expense for you is business for them. The appeal is undeniable. That feeling of thrust, that roar when you step on the accelerator, the illusion of having more car than you paid for. But every burst of acceleration reminds you of the same thing. You're using borrowed power. And like anything borrowed, sooner or later you have to return it. Number 2. Cylinder deactivation plus direct injection. Imagine your car turning off half of its engine while driving on the highway to save fuel. Sounds smart, right? Less fuel consumption, more efficiency, a technology that promises the future of mobility. But what no one tells you is that this trick comes at a hidden cost. Damaging vibrations, carbon buildup on the valves, and insufficient lubrication that slowly wears down the heart of your engine. What's sold as efficiency today could become your vehicle's death sentence tomorrow. Cylinder deactivation and direct injection have become flagships of innovation. Manufacturers promote them as technologies that will help you use less gas without losing power. And while this may seem true in the short term, the mechanical reality tells a much more expensive story. The main problem is that when some cylinders are shut down, the engine runs unevenly. This generates additional vibrations that affect the mounts, the crankshaft, and even the transmission. Added to this is direct injection, which instead of spraying gasoline onto the valve, introduces it directly into the combustion chamber. The result, carbon deposits that accumulate on the intake valves, reducing airflow and affecting performance. The key fact is overwhelming. 1 in 4 direct injection engines requires valve cleaning before 100,000 kilometers. And this cleaning isn't just routine maintenance, but an expensive procedure that requires disassembling parts and applying specialized methods such as walnut blasting. The most common example is that of Chevrolet owners with cylinder deactivation systems. Many report that instead of saving money, they ended up facing $3,500 in repairs due to damage caused by residue buildup and lack of lubrication in certain engine parts. And these aren't isolated cases. Specialized workshops report a growing trend, relatively new engines arriving with carbon-clogged valves, low compression, and misfire. The irony is that these problems are appearing in cars that are supposed to last longer thanks to technological efficiency. The cost of fixing this mess varies depending on the damage. A deep valve cleaning costs between $1,000 and $1,500, but if the problem has already caused internal damage, the bill can easily exceed $5,000. And at that point, many owners prefer to get rid of the car rather than continue paying for repairs. The paradox is cruel. While manufacturers boast of technological advances and eco-friendly engine, consumers discover too late that this efficiency comes with reliability. Because it's not just about using less fuel, it's about making your engine last. And these technologies, far from extending its life, actually shorten. Number 1. CVT transmissions divided by dual clutch plus electronic brake. Modern transmissions, especially CVTs and dual clutch transmissions, were originally promised to be more efficient and provide a smoother driving experience. But the reality is that both hide flaws that, over time, become unpayable costs. The CVT, continuously variable transmission, works with steel belts that transmit engine power progressively. In theory, it's great. No jumps, no harsh shifts, always in the sweet spot of efficiency. But in practice, those belts suffer accelerated wear. Over time, they experience jerking, metallic whining, and, ultimately, the transmission's premature death. Many Nissan and Mitsubishi owners have reported that their CVTs failed even before reaching 100,000 kilometers, a threshold unthinkable for traditional transmissions. On the other hand, dual-clutch transmissions like Volkswagen's famous DSG offer ultra-fast shifting and great performance on the highway. But in city traffic, where the car is constantly moving and braking, the clutches overheat and wear at an alarming rate. The result is a jerky ride and a transmission that can fail much sooner than expected. The cost of replacing any of these transmissions is staggering. A new CVT can cost between $4,000 and $8,000, while repairing a dual-clutch transmission is typically in the same range. In many cases, the repair cost exceeds half the price of the used car, causing thousands of owners to end up selling their cars at a loss. Added to this equation is another enemy, the electronic parking. What used to be a simple lever pull now relies entirely on an electronic module. If it fails, you not only lose parking safety, but you also have to pay for another expensive repair because the part isn't fixed, it's replaced. In short, what seemed like a technological evolution ended up being a headache. Fragile transmissions, clutches that struggle in real traffic, electronic brakes that leave you feeling overwhelmed, and a total dependence on electronics for basic functions. All of this turns driving into a game of chance where the manufacturers always wins. The result is clear. These modern systems aren't designed to last the life of car, but rather to fail much sooner, and when they do, you pay the cost.